Hello friends, welcome back for another deep learning project in the domain of natural language processing. Here we will do sentiment analyzer project which analyzes movie ratings and categorizes them into two categories. One is a positive, another is negative. So the model will take the reviews of users. So let's begin it. Before beginning, make sure you are having the accelerator GPU T4. Let's start, and in this setup I have imported required libraries like TensorFlow, Keras and NumPy. TensorFlow and Keras are for building the model, while NumPy is for numerical calculations. So let's execute this cell and initiate our runtime. So session is starting, that means runtime is starting, and let's wait a while so that session will start. You can see here we got one, that means one active event, and here it is showing interactive session with GPU T4 into 2. That means session is started and it is connected. So the required libraries are importing. After that, I have built a GPU strategy using the method mirror strategy so that we can use GPU for accelerating our training time. For that we have mirror strategy method in TensorFlow. Using that I have built strategy, and that strategy will be used in future during training. So let's run this and build this strategy for using GPU, and it will show the number of cores in this strategy. So here we have only 2 cores, because you can see here in the accelerator section we have GPU T4 times 2, that means 2 GPU T4s are in our notebook. Then I'm using the ACL IMDb dataset available in stanford.edu. Using curl and there I am downloading and fetching the data. Let's do that. So you can see data is downloading, so it will take a few seconds. Yes, data is downloaded. After that, let's go to the ACL IMDb directory and let's see what are inside the ACL IMDb directory. So in that we have imdber.txt, imdb.vocab, a readme file and test trainers subdirectories. So let's see what are inside the train subdirectory. So we have labeled bow.fit, pos, unsubbow.fit, urls, position.txt, negatives, the pos for positive and neg for negative. These are 2 subdirectories where POS contains positive reviews and NEG contains negative reviews. Then unsub is another directory which is not required for our projects. So let's remove that from the train directory. That's what I have done here. I have removed the unsup directory from the train directory. Yes, it is removed. Let's see whether the unsup is available or not. So you can see we have only two subdirectories inside the train subdirectory, that is POS and NEG, and unsup subdirectory is removed. After that, using text dataset from directory method, I am generating two text datasets, that is raw trained DS and raw val DS. The name is raw because we are using text or strings, but while we feed the model, we need to vectorize into integers to these texts. That's why before feeding we have raw datasets. That's why the name is raw train DS and raw validation DS. Here I am using the train subdirectory, then a batch size of 32 I have used, so that each batch contains 32 examples or strings or texts. Then 20% of whole dataset is reserved for validation purpose, and here another argument called subset equals to both. That means the text dataset from directory method will return both train dataset as well as validation dataset. And there is another argument seed equal to 1337 for regenerating the same datasets whenever we re-execute this notebook. After that, I am also generating text dataset from this test subdirectory and creating a batches of 32 examples in each. So let's build these three datasets, that is raw train DS, raw val DS and raw test DS. So here you can see in train subdirectory we have 25,000 files belonging to two classes, that is positive and negative, and among those files 20,000 files are reserved for training and remaining 5,000 files are reserved for validation. Then in test subdirectory the method found 25,000 files belonging to both positive and negative classes. After that, let's see few text and their levels from raw train dataset. For that, I am taking one batch from raw train dataset and iterating over three texts in that batch. So you can see this is a text. This I have seen tons of science to check it out. This is a review given by a person or someone, and which is a positive one. Here 1 indicates positive review and 0 indicates negative review. All these reviews are positive. Let's rerun so that we may get some negative reviews also. Yeah, we got, this is a negative review, the first one, and the second one is a positive review. So here you can see we have a text with punctuations and some extra characters, special characters. So we need to pre-process it before feeding to our model. And also we have some HTML elements like /br. So we need to carefully observe this, and we need to remove these tags and special characters. That's why I have created a vectorizer which vectorizes our text using a custom standardization method. So in custom standardization method, first of all we are taking a text as input to the method, then we are changing the case to lower. After that we are replacing all br text to a empty space, then again we are replacing the punctuation with nothing. So that's what our custom standardization method does, which is applied in the text vectorization layer. So for this I have imported string and I have imported regular expression. Using regular expression we can remove the punctuation, and for finding punctuations I have used the string library. We are using this custom standardization method in text vectorization layer. This text vectorization layer converts the text into vectors of integers. That's why we have output mode is equal to int, which can also be one hot, where one hot encoding is followed for converting the text into vectors. And here we have mentioned max tokens equal to max features, so that maximum 20,000 features can be vectorized at once. Then output sequence length equal to 500. That means a vector of 500 elements will be created from a text or paragraph provided to this vectorized layer. So let's run this. Oh sorry, we have not executed this cell, so let's execute. Yes. After that let's run and build the vectorizer layer. So as we know, we need to adapt the text vectorization layer before pre-processing the trained dataset, validation dataset and test datasets. So to adapt the text vectorization layer, we have adapt method which takes only text elements without any labels. That's why to remove labels from trained dataset, we are applying map method and removing the labels and supplying only the texts from the raw trained dataset, so that our vectorizer layer will adapt to the trained dataset. So let's run and adapt the vectorizer layer. So it took a few seconds, but the process is completed. After that we are using that layer to pre-process our data. So for that I have created a method vectorize text, where I am providing two things. One is text, another is label. The text will be vectorized and label is passed as it is. And before vectorizing the text, we are just expanding the dimension, and after that, using the map method, we are vectorizing the raw train ds, raw validation ds and raw test ds, and then we are caching all the datasets, and also we are prefetching. The cache enables the RAM to fetch the data quickly. Prefetch allows the TensorFlow to preload the data of next epoch in the current epoch. So let's vectorize all the data and convert the raw train dataset to train dataset, raw validation dataset to val dataset, raw test dataset to test dataset respectively. Let's run it. Yes, all the raw train dataset, validation dataset and test datasets are converted to train dataset, validation dataset and test dataset respectively. After that, we will build a model which will take the integer inputs and classify the text based on the feature maps. So for that, I am using a method to build the model, and inside the method the input it is taking is int 64 because the texts are converted into vector formats and vector contains integer values, and as we don't know the shape of the badge, that's why the shape is equals to none, and here the inputs is that vectorized text. Then we have a embedding layer which will converts the inputs or vectorized texts into feature indices to a vectors of 128 indices. So embedding dimension is equals to 128. That means this embedding layer will return a vector of 128 elements. So all the inputs, that is vectorized text, will be embedded, and indices are generated through this embedding layer. Then we have a dropout layer which drops 50% indices. Then we have convolutional 1D layer with 128 filters, 7 into 7 kernel size, and we have valid padding with ReLU activation and strides equals to 3. This layer is repeated twice, and then we have a global max pooling layer which will pulls out the features found by the convolution layers. Then we have a vanilla hidden layer, that is a dense layer and a dropout layer. In the dense layer we have 128 units of neurons and ReLU activation function. Then we are dropping the 50%. After that, we are using a dense layer for classifying the outputs into positive and negative, and for that we are using sigmoid activation function which returns a value between 0 and 1. So if the value is greater than 0.5, we will consider that to be positive, and if the value is less than 0.5, then we will consider that to be negative review. So using a functional model, we are building the model and returning the model. So let's run this and build our model. After that, we will compile our model under the strategy scope, and as the model is predicting only two classes, that is either positive or negative, that's why we are using binary cross entropy as loss, and as usual we will use Adam as optimizer and accuracy as matrix. So let's build and compile the model under the strategy scope. After that, I'm training the model. To train our model, we have fit method where I'm providing train dataset and val dataset as validation data, and for 5 epochs we are training the model, and we have checkpoints as callback which will save the best weights and which monitors the validation accuracy and saves all the weights in the model underscore checkpoints.keras file path. Let's train our model. So it won't take much time because it is text data, not image data. So no need to speed up this training. You can see it just took 19 seconds. So after first epoch we have training accuracy 0.59, that is 59%, and validation accuracy 86%. After second epoch we have 88% training accuracy and 87% validation accuracy. After third epoch we have 94% training accuracy and 86% validation accuracy. After fourth epoch we have 97% training accuracy and 86% validation accuracy, and after fifth epoch we have 98% training accuracy and 86% validation accuracy. So let's evaluate our model through evaluate method, and here we are evaluating the model for test dataset. So let's execute this. Here you can see the test dataset evaluation resulted to 86% and loss of 0.55. Let's fetch the best model from checkpoints we that saved just now and evaluate that too. So the best model resulted to 86% and a loss of 0.33, and let's do the inference for this model. So in inference I have created a method called sentiment analyzer which will take a text as input. Then for that I'm expanding the dimensions, and then using the vectorized layer we are converting the text to vector, then using the best model to predict, and if the prediction is greater than 0.5 then we are printing positive review, else we are printing negative review. So let's run this. After that, using a find a review method we are taking out one random review of raw test dataset and printing that review as well as returning that review. So let's run it. So now let's get a review from the find a review method. So you can see I would have to say that in general Barbie movies have impressed me. I have a 5-year-old Barbie fanatic niece and she watches them all the time, so needless to say I have seen quite a lot of Barbie these holidays, but I am not sick of them. This film visually has lot to offer, especially the backgrounds and the animations of the characters has improved with each new movie. One thing I noticed in particular was a vast improvement in the animation of Barbie's hair in this film. It has a lovely range of excerpts from classical music, and I think that this is great as it exposes a new generation to the classics. This film is well worth a go, especially if you have young relievers. They will be entertained for hours. So it seems like it is a positive review. Let's go for sentiment analyzer, what it will return. Let's see that. So let's run this. So you can see the model returned positive review. That means the model is predicting accurately. Let's go for another review. Let's rerun this. So this is a big paragraph. Let's go for sentiment analyzer. So it is also a positive review. Let's copy and rerun this. Let's copy this, paste over here, find a new review. Yes, this is another new review. Afraid of dark left me with some impression. You may read and check this. Let's go for the output of this. So it's a negative review. Yes, you can see, my dear friends, the model is predicting accurately. This is a short video, but it will help you a lot. We have implemented the sentiment analyzer from the scratch. So thanks a lot, and it is the beginning of our NLP projects. Stay tuned. Have a great future. Thank you very much.